Assalamualaikum warahmatullahi wabarakatuh. Today we're going to discuss our group project and it's about techniques of differentiation. First of all, I want to introduce my group members. First, our team leader Muhammad Faris Aiman bin Muhammad Fauzan. Next, Abuza bin Shahrum. Third, Muhammad Fauzan bin Ahmad Nasruddin. And lastly, Muhammad Irfan bin Fazli. Question 1. Explain the meaning of differentiation and describe the techniques of differentiation. Differentiation and derivative is simply a measure of the instantaneous rate of change. It is a concept of real variable that measures the sensitivity to change the value of a function with respect to the change in its arguments. It is used to measure the rates of change of a function y equal to fx with respect to its variable x. To make it understandable, have you ever wondered how fast something is changing right now? That's exactly what differentiation helps us figure out. Think of it like a speed. If you're driving a car, your speedometer shows how fast your position is changing right now. That's exactly what derivative does for function. It gives you the speed at which the function value is changing at any given point. Next, the technique of differentiation. There are three techniques that we need to understand, which are product rule, question rule, and chain rule. First, product rule. The condition UMV must have multiplication in the middle. The step, we need to identify which one is U and V, differentiate the U and V to get U prime and V prime, and put all the value inside the formula fx equal to U multiply V prime plus V multiply U prime. Second, question rule. The condition U and V must have fraction between of it. U equal to numerator function, V equal to denominator function. With the step, we need to identify which one is U and V. Differentiate the U and V to get U prime and V prime, and put all the value inside the formula. F prime x equal to U prime multiply V, subtract U multiply V prime over V square. And the third one, chain rule. The condition, there is an inner expression in a function. The step, we need to differentiate the outer function. After that, we must differentiate the inner function and multiply with the coefficient.
Assalamualaikum, my name is Abuzar and I'm going to explain on how to solve question number 2. So to find the derivative for the following functions, we are going to apply product rules. So we have to find u and v and differentiate each of them. So now that we have them done, we are going to substitute the value into the product function. So we have 2x to the power of 4 times 6 exponent 6x plus exponent 6x times 8x cubed. So we have 12x to the power of 4 exponent 6x plus 8x cubed exponent 6x. So now we can simplify them by factoring out x cubed exponent 6x. So the final answer is x cubed exponent 6x bracket 12x plus 8. So for question B, we are going to apply chain rule. So we have to transform the function into composite function. So the function will be ln bracket ln ax minus 8 to the power of 5. So we have to differentiate the outer function times with differentiation of inner function. So it will be 5 bracket ln 8x minus 8 to the power of 4 times with 8 over 8x minus 8. So now we can simplify the differentiation of inner function. So it will be 1 over x minus 1. So the final answer will be 5 times 1 over x minus 1 times bracket ln ax minus 8 to the power of 4.
Assalamualaikum, my name is Faris, and before we get into question number 3, I would like to talk about implicit differentiation. Implicit differentiation is a technique that are used to find the derivative of a function when the relationship between the variables is given implicitly. So the technique that I mentioned before is differentiating of each side, which is the left side and right side, of an equation with two variables by treating one of the variables as a function of the other. Here are some examples of implicit function. So clearly, there is a difference between explicit function and implicit function. So, how to do implicit differentiation? The first step is to differentiate both sides of the equation and make sure to treat y as a differentiable function of x. The second step is to collect terms with dy dx on one side of the equation. The third step is to factor out dy dx, and lastly it is to solve for dy dx. With all of that in mind, let's answer question number 3. So the question is cotangent 2x plus exponent to the power of y plus 1 over x equals to ln 9x minus open bracket x plus 7 close bracket to the power of 6 minus y cubed. Now, remember the first step? We will have to differentiate both sides. So the first term is cotangent 2x. Differentiating that, we will get negative 2 cosecant squared 2x, and differentiating exponent to the power of y plus 1 over s using the quotient rule technique, we will get x exponent to the power of y plus 1 dy dx minus exponent to the power of y plus 1 over s squared. The reason why we have dy dx is because every time we differentiate with the variable y, we will have to add dy dx on the back. Either on the back or at the front, it doesn't matter as long as you add dy dx every time we have the variable y. Every time we differentiate the variable y. Sorry. Moving on, equals to differentiating ln 9s, we will get 1 over s, and differentiating open bracket s plus 7 close bracket to the power 6 using the chain rule technique, we will get negative 6 open bracket s plus 7 close bracket to the power of 5, and lastly is negative 3y squared dy dx. Before moving on to the second step, we will have to multiply with x squared because we cannot have any variables on our denominator. So after multiplying it, we will get negative 2 x squared cosecant squared 2x plus x exponent to the power of y plus 1 dy dx minus exponent to the power of y plus 1 equals to x minus 6x squared open bracket x plus 7 close bracket to the power of 5 minus 3x squared y squared dy dx. Now, on to the second step, we will have to rearrange and collect all the dy dx term on one side. So, after rearrange and collect all the terms, we will then have to factor dy dx out of the term, and then we solve it to get dy dx, and that is the way and the answer for question 3.
Assalamualaikum and hello everyone. My name is Muhammad Fauzan. Now it's my turn to explain question 4. So from this question, we know that it's about the linear approximation because the question mentioned the word estimates. Now, for this question, use linear approximation to estimate the value of ln 5 minus 2 multiplied 2.09 plus 8 over 2.09 square and give the correct answer to 4 decimal places. So how to solve this question? First, we have to identify the x, which is in decimal number, which is 2.09. I highlight with the orange color. After that, we have to find the fx in terms of x. That means, so from the questions is ln 5 minus 2x plus 8x to the power of negative 2 after I transform it because we have to differentiate after that. And then we have to find the x approximation, which is the 2. How I got 2? Based on the yellow highlight color, which is I just do one term, which is 8 over 2.09 square because it's additional operations. So I solve it and got 1.8315 and it's around integer 2. And we can double check it with the 8 over 2 square so that we confirm that approximation x is 2 based on the green highlight color. After that, we have to find the fx approximation. We just substitute the 2, which is ln 5 minus 2 multiplied by 2 plus 8 over 2 square, which is 2. After that, we have to differentiate the functions, which is negative 2 over 5 minus 2x minus 16 over x cubed. And then I substitute the 2 into the function I differentiated with this, which is negative 2 over 5 minus 2 multiplied by 2 minus 16 over 2 cube, and I got negative 4. Now we have to insert the value into the formula, which is fx approximately equals to fx approximation and plus f prime x approximation multiplied by x minus approximation x. That's the formula. We just put the value of into the formula and got 1.64, but the question mentioned to have in four decimal places, so just add 0 and the final answer will be 1.6400. That's all from me. Thank you.
And lastly, conclusion. This project has helped us understand the key concept of differentiation, such as the rules and how they apply to the real world problem. Differentiation is an important tool in science, business, and everyday life for analyzing change. Recommendation: we suggest exploring second derivative and real-life application like motions or cost analysis to deepen understanding. Using visual aids and solving practical problems can also improve learning.